Good morning, everybody, and welcome to our webinar, The Evolving Cybersecurity Threat. And today we're going to be talking about cryptomining. So my name is Tony Mannion, and I'm going to be hosting. And I'm Sales Development Manager here at Solutions PT. So just having a little look at the agenda. First of all, I'm going to perhaps spend a couple of minutes just explaining why we're talking about cryptomining, what we're actually seeing in the market that has prompted the webinar today. And then I'm joined by two of our product managers, and I'll introduce those shortly. And we're going to have a bit of a discussion about cryptomining. And at the end of that, we'll also hopefully have some time if you have any questions that you want to send in. There is on the webinar a question and answer box, so if you wanted to type your questions into that box, at the end we'll see if we've got time to answer those questions. Any that we can't answer or that we haven't got time to answer, hopefully we'll be able to respond to you after the webinar. So what I wanted to do is just have a look, and these statistics that I'm going to look at are taken from the Trend Micro half-year figures for the second half of 2018. But I think what they do is give us a view of what we're seeing and what's reflected to us from our customers as to what they're seeing from a cybersecurity perspective. So the first figure, we've been talking a lot over the last 5 years about ransomware, and ransomware has been growing at an incredible rate. But what we saw in 2018 was a massive slowdown in the growth. It is still growing, however, so ransomware is still a big problem out there. It is still something that people are very wary of. But actually, in the second half of 2018, we only saw a growth rate of 3%, which was hugely down from previous years. So although it is growing, it's perhaps not growing at the same rate as we were expecting. And we've also seen a massive increase, or massive decrease rather, 26% in the new ransomware families. Now, while that's quite a large percentage, we do have to bear in mind that there are millions of ransomware families that are being developed each year, different variants of the families rather. So we are still seeing some growth. Ransomware is still a problem for our customers. It's still something we need to be aware of, but we are seeing a slowdown in that growth. And actually part of the reason for that slowdown could be because we have seen this massive growth in cryptomining attacks. So from 74,000 in the second half of 2017, up to over 750,000 in 2018. So again, massive growth. And one of the reverses that we've seen with the ransomware, we're seeing new families of the cryptocurrency mining malware being found. And the more families there are, obviously the more difficult it is to detect and protect. So again, this is a growing figure that we need to be aware of. So we are still seeing an increase in the vulnerabilities within our systems. We know a lot of people are running legacy systems and they are more vulnerable. But one of the interesting factors is that we've seen a 77% decrease in Scarda zero-day attacks with no patch. Now, what this says to me is that as an OT community, we are getting better at using technology to protect our systems, whether it's an introduction of a more resilient patching regime, because we are being more aware of the attacks, or whether we're using technologies to help us. So a lot of the things we've seen over the last few years are the likes of terminal services allowing us to maintain patches at a server level rather than at each client, and people are able to apply patches a lot easier and a lot quicker because of the architecture, and also things like virtualization. helping with vulnerabilities that are found in legacy operating systems. So some of the work that we've done, we're seeing some really good results. But because of that, we might start seeing this increase in crypto mining as a new way of criminal organizations to make money. So I'm going to talk a little bit about crypto mining with two of our product managers. So we've got Chris Whitehead here.
Good morning.
So Chris looks after our managed platform product set. And I'm also joined by Lee Carter.
Good morning, Tony.
And Lee looks after industrial networking and cybersecurity products. So I've got a number of questions here that I'd like to go through with you guys, and then, as I say, we'll open it up to any questions from people who are tuned in. And I guess the first question, I'll put this one to you, Chris. I guess it's important to know, we're talking about crypto mining. What is crypto mining?
Okay, so essentially crypto mining is the latest threat as an evolution from ransomware. So traditionally, most people are probably comfortable with the concept of ransomware, which is where your system's compromised, the application runs in the background, it encrypts your files, and it presents you a lock screen, which essentially says you need to give us so many chunks of Bitcoin or so many $100 worth of Bitcoin, and then we might release your information back to you. The stats you presented before, we've seen a huge increase over the last few years of that, and that increase has slowed down. Most people are now aware of it and are taking steps to protect against ransomware. So this has led the criminal underworld, if you like, to look at a different way of extracting money from people. And actually, the value drop on the Bitcoin has pushed them to look at things more effectively. So rather than trying to mine them themselves, which is essentially using a processor to run, if you like, calculations against a complexity of questions in response to actually gaining chunks of Bitcoin as a payment, because the values drop so quickly, they've looked at actually, how can we do this? And that's led them to develop crypto mining, which is essentially where, rather than locking your screen and saying, holding your data to ransom, they turn around and basically, well, we're going to use your PC, but in the background without you knowing it. So rather than paying server farms or run it on their own machines, they use a distributed network of numerous exploited machines to mine coins for them. So you don't actually see that traditional lock screen and the demand for money. What you might see is your system starts to run that little bit slower. And that's because in the background, it's running these calculations to mine the currency for someone else. So it's still ransomware-esque, but it's not holding data to ransom. It's holding your system to ransom. So an exploited system could be used to mine coins for someone else. Okay,
so I guess if I'm hearing this right, you're using sort of excess resources within the system and bringing them together to have one large system that's doing this crypto.
Precisely. Yeah, essentially the more processor you've actually got running this, the more effectively your hours of, if you like, processing time would have a better yield.
Right.
So one PC might be able to turn around a tenth of a coin every week. If you've got 1,000 exploited systems, you'll be turning around numerous coins daily, which is much more profitable. So they're looking for high penetration levels to get as many systems exploited and use as absolute much of that processing power as your system can handle, with no real thought of how it would impact you. They don't care if your PC is running slow or it takes you an extra few minutes to open an email or open a file or do something. They're after just using as much of that processor time as possible to gain the most possible impact from it.
So Lee, I guess listening to what Chris is saying there, should crypto mining be a problem for our customers? Should our customers actually be worried about this?
They certainly should be, Tony. First things first, I think it's important to note that the fact you've got crypto mining software on your system might mean that you've got someone who is unwanted in there. The likelihood is that somewhere along the line they've been invited in, so the software's come in possibly by social engineering. Somebody might have installed something that was a bundled piece of software, and that's how that's actually put on there. Now, the fact that you've got theft of your processor power, theft of your electricity, that's what's happening now. Now, what's going to happen later on? Because they've got a foothold in your system, so they can do other things at a later stage. At the moment, it's about taking the money. It's about taking the processor power to create the Bitcoin. Now, the performance impact that this might have on your systems is that might just push your critical systems to a level where you're starting to see some problems. You might be seeing some anomalies, you might be seeing some dropouts. If it's a very critical process, it might be dropping the quality of your product. So, you know, you've got some additional problems coming later on from there. And I think wider scale, your systems can then also be used to launch other attacks to other places as well. So you might form part of a bot network at some point in time that could be used for other things. I think cryptomining is very, very serious, and having that on your system is just the thin end of the wedge.
Mm-hmm. Yeah, but certainly one of the scary things you mentioned there was affecting the performance of the system, and we know in the OT world that's a big concern. So Chris, if people understand the problems that this could cause, and they are looking to prevent these types of occurrences, I guess they've got to know how it's actually spread. So what sort of tools are people using, and what have we seen? Well,
essentially, the people who are, putting this into practice are going for mass penetration, as many infected machines as humanly possible. So we've not seen many, if you like, spear phishing, dedicated, focused, profiled attacks on individuals. What we've seen is essentially the typical spam emails with links in it. There's been numerous reported advert systems that have been compromised. So certainly Yahoo were affected by it, Google have been affected by it, numerous people. And essentially what they're doing is putting these adverts in with what we would call clickbait. So adverts that are really attractive for people to try and click on that will direct them to a website. Apart from, rather than trying to send them to a website to sell them something, these websites are then running the malicious code in the background or asking them to download a file to, claim the prize that they've won. And it only takes an inadvertent click of one of these bad ads, if you like, and you're directed to a malicious website that's downloading the code and is then running it. So that's where most of the infections are coming from, these bad advert systems, emails, spam, the usual routes. But also they're looking at known Windows vulnerabilities. So where attackers would traditionally look at how to attack a protocol, how to exploit a known vulnerability within a system, they're kind of playing on the fact that some of these control systems don't get updated that frequently. So the latest exploits where there's patches and fixes for it, they're taking that chance that actually these people have probably not applied these patches to a control system because they understand the vulnerabilities and risks in doing so, which means that actually they have access to the vulnerabilities there. They know how that vulnerability plays out, and can then use that to actually inject that malware system into the control system, into the corporate side of it, and actually get it to transmit through. And unfortunately, once it's in there, some of them are actually almost airborne. They will find a way around the network to find any other machines that got the same open ports and exploits and spread themselves.
And we've seen that a lot with other infections, where once they actually have infected a machine, one of their purposes is to go out there and find other machines too.
Yeah, so it's a law of, if you like, magnitude. So one machine will probe the rest of the network and maybe find one or two others, but then you've got three machines probing the network trying to find others. And it can spread from something as inadvertent as a contractor comes in with a laptop and accidentally connects it to your control system. So the exploit might not run on their version of Windows because it's patched, but it will spread. Or they transfer a couple of PDF files, which are then common exploits that we see. So things like instruction manuals, user data files, that sort of stuff. And once it's in that control network, it will spread like wildfire, because typically it's not going to be as up-to-date with the antivirus, it's going to be up-to-date with the patching and vulnerability fixes. So it only takes that one initial infection, and then suddenly you start having 10, 20, 30 machines, endpoints, laptops, workstations, whatever, all probing each other to try and find new machines and new ways of spreading that infection.
So Lee, one of the things that I was quite concerned about, just listening to what Chris was saying, ransomware, you get a splash screen so that you know you've had an infection, but with this you don't. So how do our customers know that they're actually being attacked, or even worse, that they have been breached previously?
Good question. I think customers need to understand what their assets are and how their process fully operates. Quite often you've got skilled engineers who maintain and manage these systems, and they are the people who are accountable and responsible for looking after that. But they're busy people, and they don't always have the tools and information necessary to make all the judgments that they need to make. The key thing, obviously, for cryptomining is ensure that you're monitoring the performance of your system, ensuring that any spikes that you might see are accounted for. If you see some early warnings, you need to take those into account and investigate them through, and don't ignore them. You should also as well look at what's happening on your wider network, so ensuring that you can account for traffic which is going on and off, because this data is going to be exfiltrated somewhere, and that's likely to be onto some public network that's out and about. I think summing up, you really need to have decisions based on key information. So it's not just engineers going from a gut feeling that says, well, it just does that from time to time. You need to take the time and effort to investigate it, find the root cause, and ensure that that isn't happening to you.
So knowing what's happening on the system and knowing what should be happening on the system are going to be hugely important to identify these.
Absolutely.
Yeah. So, Chris, if you are monitoring your system, should you be able to identify issues early enough then?
That's a great question, and I suppose the answer kind of comes in thirds. Yes, monitoring would allow you to find it early enough, but there's kind of two other components that are critical to go with that. Monitoring it alone, like Lee says, is important, but ultimately it's not everything. You need to have a good baseline to understand what the deviations away from your normal operating system would look like. So, let's say you're running application X, and application X uses 10% of your processor all day, every day. Without having that historical baseline of information to work from, if you just looked at the monitor and says, okay, the CPU is now using 30, 40, 50%, without that comparison against what it should be doing, you don't really know what the anomaly is. Monitoring it in itself is just being able to look at the system and go, okay, CPU's a bit busy on that one. Like Lee said, is it just an engineer going, yeah, it does that from time to time? Have you got something to be able to compare it to? And the other side of that is knowledge. So actually understanding what that application should be doing. So if you've got an application of a certain size, a certain density, a certain number of I/O points, what is the expected consumption of resources? How much memory should it be consuming? Is that in the right kind of spec for what it should be doing? And actually what we've done with other customers via Solutions PT is we've monitored these systems using a tool called Auxilia. And that does allow us to take those baselines and allows us to cross-compare them against systems of a comparable size. So we know that if application X has got so many I/O points, it should be in this kind of band of CPU consumption. It should be using so much memory. And that makes actually identifying these potential infections or issues a lot more effective, and certainly happens a lot faster.
And I guess we certainly know that in our marketplace, we have been suffering over a number of years from lack of qualified people coming into the OT environment. So
Absolutely.
If people can't do it themselves, this is a big problem for them.
And also, you touched on the point earlier, everyone is busy, and finding the time to sit there and look at these systems in real time to get usable information out of it. If you've got a stretched schedule of what you've got to do every day, trying to find another hour or two every day to go through these logs and look at stuff and actually turn that information into usable data, it's a challenge. It is a real challenge, and that's where Auxilia comes into its own.
Thanks, Chris. And Lee, I guess where we differ from our friends in the IT world, we know that with a control system there are different cycles as we go through the day, so we would expect to see a different performance across the resources in that environment. So how are people able to differentiate between what could be a malicious attack and what's actually just normal operating for a control system?
I think Chris has touched on this previously, which is about understanding baselines. But you need to have more than just a baseline. You need to understand what is the pattern of life on your network. So that's understanding when you've got a time in your process where you might be only using a certain amount of traffic, a certain amount of CPU resources. But it's more than just the CPU resource of the device itself. It's understanding the communication between a PLC and maybe a controller or another management station. So having a product which can look at these communication paths, can actually understand the intricacies of an OT network and be able to say, hang on, I've not seen this kind of communication before. Is that correct? Is this something different? So that you can look at it in a little bit more detail. CPU utilization is only one aspect of something which is actually going wrong. Being able to track your network communications from point to point is also a very integral part of any security stature, just to make sure that you know what you're doing. I don't think we can't rely anymore just on people's hunches and gut feelings of it does that. We're moving to a point whereby we need to have evidence-based investigations on points and problems that need to be validated correctly.
It's a really good point, and actually it's a lot of the feedback that I've had from customers when I've been out talking to them about cybersecurity, and especially in relation to things like anomaly detection with Clarity, one of the products that we've brought into our portfolio, is without a tool that's able to do that and is built for the OT world, people just don't have that level of visibility anyway.
That's absolutely correct. And there's some great IT tools out there, but they just don't understand the OT world.
Yeah, good point. So, Chris, I guess people listening or downloading the webinar at a later date are going to be thinking, okay, let's go and investigate what's happening. If somebody did identify something that could have been an issue or could relate to some of the hacking into their system, what sort of steps can they take and should they take?
There's probably numerous steps you could take, and I guess a little bit will depend on your internal processes and procedures, but essentially, if you've kind of got carte blanche of, you discover one of these potential infections, what do you do first? And for me, the first step I would do is isolate that potentially infected machine, because the last thing you want to do is, while you're investigating what's going on, is that starting to spread, because then you're doubling your workload. And very quickly, these things could take over numerous machines on a network and really, really cause you a huge problem, particularly in that kind of control system environment. So isolate to begin with, and this is where you really need to have a really robust DR procedure, policy, and technology applied to the system. So you need to recover quickly, but there's a parallel task in that. You need to understand where that infection's actually come from. So kind of root cause analysis. So what you don't want to do is just immediately start your recovery process and flatten the system, because essentially you could be putting the recovery point back onto the system that's still got the same hole in it that's going to allow reinfection in the future. So actually got an example. We did this with a customer a couple of weeks ago where they're using our Proteus service. So we had one of these potential infections occur. We were notified. They isolated the system. We went through essentially a parallel recovery. So we isolated the physical machine that was potentially infected, and we ran up a locally virtualized instance of the same machine. So the recovery time was just a couple of minutes. While we turned on the virtual machine and put the system back into production, the isolated machine was then gave us the time to be able to allow their security guys to interrogate it and understand where the actual root and cause of the infection had come from. So actually, what patch needed to be applied for it, where's the actual infection rooted from. And then once they actually figured that out and the patches and everything were applied to and the system was recovered, then merged the data from the running VM back into the live system. So actually, the total downtime was just a couple of minutes, where in parallel, if you'd not had a robust system, you could be talking downtime of a couple of hours or even worse, days.
It's an interesting point as well, Chris, the really good point that you've made. A lot of the feedback that we get is that our customers, because of the challenges of production, because of the need to have this high availability of the system, they often don't have the ability or the time to be able to go in and investigate and do a causal investigation into what's been happening on the plant. So actually being able to have that time should make the system more secure.
And I would argue it's probably as important as having the DR structure, because, again, if you're just going to blindly take a backup that you've taken and run it back onto a system and try and recover your production data, like they said, unless you're doing that root cause analysis to understand where it's come from, you could just be opening up the same holes again and leaving yourself wide open for another infection a couple of weeks, couple of days, months down the line, and essentially you're not protecting yourself from future downtime in doing that.
Yeah, really good point. So Lee, we've just heard about what perhaps somebody should do if they find an infection, but I suppose a lot of our customers maybe haven't considered cryptomining as a possible threat to their systems until quite recently. So maybe what steps could they take now, or maybe should they take?
I think the first steps that they should take, Tony, is to understand the assets that they currently have. And this is something that resonates with me whenever I've gone and done security audits at customer sites. There's always a device that's about which has been something that's been left in a corner, something that's not accounted for. So understanding what you have on your estate allows you to then, first of all, be aware of that so you can look to protect it. Secondly, I'd suggest doing something like a security posture analysis. Now, this is something that we've helped a number of our customers with here at Solutions PT. Now, I think to be clear, this isn't a penetration test. This is having a look at the data flows that are happening between your devices and being able to enumerate a lot of information about the level of firmware, the protocols that are in place, the communications in a very passive way so it has no impact to your process. A lot of customers that I've spoken to before in the past believe a penetration test is the way to go. I disagree with that being a penetration tester. There is a place for that, but that's after you've done your security posture analysis. I also think a number of our customers need to take some very basic steps as well. What they need to have a look at is some of the really low-hanging fruit. So make sure that things like your default passwords have been changed. If you're using SNMP, change the community string. If you've got an external network that's connected, have a firewall in place. We see too often that customers have flat networks that traverse between IT and OT, which allow the cross-contamination of traffic, which really shouldn't be in place. And last but not least, I think it's very important to have your infrastructure validated. And that should be done by someone external to your organisation that can point you in the direction of things that possibly need to be done. All too often, when you're an IT professional or an OT professional and you're working from day to day, you think, I'll come back and I'll finish that off. But you never do. And what these independent validations do is probably let you know what you already know and then just chivvy you on so that you can just finish that task off.
Great point. We've all done it. It amazed me as well, Lee, another really good point there. When I first started looking at cybersecurity was the benefits you can get from doing some of the low-hanging fruit. And actually the low-hanging fruit will get you so much further on reducing the risk that your system could be under. So, yeah.
You're absolutely right, Tony. The NCSE has some great collateral that you can just have a look on there, some really quick, easy steps that can just take you to a really good place.
Excellent. Guys, thank you for that and for answering my questions. I'm just going to have a quick look now and see, have we had any questions come in from our attendees? There's a great question come in and a really topical one. A lot of people are talking about the industrial Internet of Things. People are talking about Industry 4.0. And we've had a question come in. Are wireless networks or IoT devices more susceptible to these type of threats? Lee, what's your thoughts on that?
This is one which I'm going to have to give a yes and a no answer to. Yes, they are slightly more susceptible by the virtue that a lot of these devices will connect to external networks, maybe wireless networks. You might have emanation of signals that are going outside of your boundaries, but as long as you control everything that's going on, the truthful answer is no, they're not. Vendor selection in these devices plays a really large part. If you buy a really cheap device from Amazon at a couple of pounds, you're not going to get much support. But if you go through a vendor which is going to guarantee to give you longevity of support, you're going to get updates. So any flaws and vulnerabilities that are found, that you can actually get those patched, and you'll be back up to speed. Implementation. So you need to plan to put these devices in. Don't rush just to go and get the next new shiny thing which is going to be on your plant. Plan it in correctly and make sure that you put compensation measures around just to ensure that the device is going to be as secure as it needs. And just comes back to a few things that we've mentioned earlier. There's a need to monitor. Just make sure the device is monitored.
Perfect. Okay, thanks for that. And for me, this is a really key topic because I do hear customers still saying that there's a reluctance to adopt new technologies that will help drive efficiency within their business because of this worry about cybersecurity. But I guess it's the same as anything. By following best practice, by making sure that you cover all of the steps, you're probably in as good a position to introduce it as sitting with your existing systems. So
you're absolutely right, and the NCSEs actually acknowledge the facts in their secure design by saying at some point you may be breached, and being able to see that breach quickly and be able to action on it is key.
Fantastic. Well, we haven't got any more questions come in, but I'm sure we might have following this, and I will give details out later on. But guys, that was really useful. Thank you very much for that. I guess just some of the facts that we can use to summarise. We are seeing crypto mining as something that is growing in the industry, and we understand how the route to money is made, and therefore it's something that people are investing in. Ransomware does remain a threat, although it's probably, I guess, because of the publicity about how people can protect themselves, it's not growing at the same effect. Crypto mining should be a concern to our customers because it can have a detrimental effect both on the running of the systems, but also you're allowing somebody onto your system, which could lead to a lot of problems going forward. Risk of downtime, which we know is a big issue for our customers. And the biggest thing for me is it's the importance of knowing your system. It's the importance of having visibility of your system. It's the importance of knowing how your system should be running, and then maybe giving yourself time in the event of a breach to be able to investigate how somebody was able to get into your system. So there's a lot of takeaways from what we've spoken about today. So thank you very much for that. And obviously everybody's different. Everybody's plant is different, works in different ways. We've talked very generally here, but more than happy to get involved with each of our customers to understand their situations and what we can do to help them. So if you do want to find out more, there's an email address that you can come through on info@solutionspt.com. We've got our telephone number, give us a call, or go onto our website at www.solutionspt.com, and you'll be able to see an overview of some of the ways that we're helping our customers. But come and talk to us because, again, being able to help you understand how other people may be protecting against these attacks may give you some ideas as well. So thank you very much, and we'll hopefully see you at our next webinar.